Hello. I would like to remind you what type of supports we have. We have three different types of support. The first one is called the fixed support. If you have this support, we should expect three reactions, one vertical, one horizontal, and one moment. If you have a hinge support, we should expect two reactions, one vertical and one horizontal. If you have roller support, we should expect only one reaction. This reaction is perpendicular to the base of the roller. To figure out these reactions, we need to apply three equilibrium equations. Summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. I will do an example on reactions. We are given this beam. A is a roller, B is a hinge support, and we need to figure out these reactions. First step, I need to set up my reactions first. A is a roller, so we should expect one reaction at A, YA. B is a hinge, that means we have two reactions at B, YB and XB. Once you set up your reactions, I will apply my equilibrium equation. Summation f of x equals 0. Summation f of y equals 0. Summation moment at any point equals 0. So if you apply summation f of x, what forces do you have in x direction? We have only negative xb, nothing else. That means your reaction xb will be 0. So this reaction will be 0. Summation f of y equals 0. We have positive ya, we have positive yb, we have negative 5 kip equals 0. I cannot do anything more because ya and yb are unknowns. Summation moment at any point. I do recommend to take moment at the point with the maximum number of reactions. So I'm going to take moment at B. I'm going to assume my counterclockwise rotation is my positive direction. It's up to you. You can assume any direction is your positive direction. So I have XB time distance. I have YB still need distance. I have YA time distance. I have 5 kib time distance, and 18 kib foot does not need distance equals 0. Keep in your mind, XB is a force. Still need distance to create a moment. YB is a force. Will need distance to create a moment. YA is a force. Need distance. 5 kib is a force. Need distance to create a moment. 18 kib foot, this load is a moment. Does not need distance. Does not need distance. So what is the distance between XB and B? 0. YB and B? 0. YA and B? 12. And keep in your mind, the distance and the force must be perpendicular. 5 kib at this location and B, it will be 18 foot. What is the direction? I don't care about this one. I don't care about this one. Both of them will be 0. YA time 12 will rotate clockwise. That means it's negative because I assumed the counterclockwise is my positive. 5 kib time 18 will be positive, rotating counterclockwise. This moment is given counterclockwise will be positive. The only unknown in this equation is YA. I can figure out the value of YA. It will be 5 times 18 plus 18 divide 12. I got 9. Kip. 9 positive. So this reaction YA equal 9. Positive means I assumed the correct direction, which is up. Go back and put YA equal 9. I can find out the reaction YB. It will be negative 4. So this reaction will be negative 4. Negative means I assumed is the wrong direction. This reaction should be down, not up. That makes sense? This is how to figure out the reactions for any given beam. Keep in your mind, this beam or any member in your structure will be under the effect of external forces. So this beam in this reinforced concrete structure under the effect of external forces. We are in any building are considered external forces. If you have wind or earthquake on the building, they are considered external forces. These external forces will create internal forces in three forms: axial force, shear force, and bending moment. Let me explain what is the meaning of each. Axial force, which is called sometimes normal force. If you have a force and this force F parallel to the beam, here is your beam. Your beam is horizontal and your force is parallel to this beam. That means this force will create axial force. Sometimes this force is pushing the beam. That means this beam under compression. Sometimes this force is pulling the beam. That means this beam will be under tension. So keep in your mind, if your beam in a position like this or position like this, I don't care. The force that will cause axial force is a force parallel. Is a force parallel to the beam. Sometimes this force is tension like this one. Sometimes your force is compression like this. Tension means pulling, compression means pushing. The second internal force, which is called shear force. If your beam under the effect of perpendicular forces, so the force that will cause shear is a force perpendicular. Imagine we have two opposite perpendicular and parallel forces. This one, F1, and this one, F2. F1 trying to push this part of the beam down like this. The second force, F2, trying to push this part of the beam up like this. In between, we should expect shearing. This is the effect of shear force on the beam. So keep in your mind, your beam under the effect of forces perpendicular. These forces will cause shearing of the beam. Bending moment. If you, the term moment equal force time distance. Your force and your distance must be perpendicular. So if you have a force and you have distance, both of them are perpendicular. That means we should have a moment. If you have a moment on your beam will bend. What you mean by bend? The original shape of your beam is straight. After you have a moment, this straight line will be a curve. That means your beam started to bend due to the effect of bending moment. So what we should learn in this part, we will be given a beam. This beam under the effect of external forces. These external forces will create internal forces in three forms: axial force capital N, shear force capital V, bending moment capital M. I will give you a specific point like this point. And I will ask what are the values of the internal forces, axial force, shear force, bending moment at this specific point. We have few steps we need to follow, 4 steps. The first one in these steps, I will do reactions. I will calculate the reactions. Second step, I will do section. At this specific point, I will do cut section. This section will divide your beam to 2 parts. One on the right hand side and one on the left hand side. Which part I'm gonna use, it's up to you. I can use the right part or the left part. Then I will put my internal forces, axial force, shear force, bending moment, and then I will apply the equilibrium equations to find out these internal forces. Let's start to do some examples. I will start with this example. We are given a beam and we are given a certain point or a specific point C, and we are looking to figure out what is the axial force capital N, what is the shear force capital V, what is the bending moment capital M at this specific point. As we remember, the first step, I have to start with reactions. I will start with reactions. So go ahead and start to set up your reactions. Based on the given information, A is a hinge. So I will have 2 reactions at A, YA and XA. B is a roller. So I will have one reaction at B, YB. Then I will start to apply my equilibrium equation. Summation f of x equals 0. Summation f of y equals 0. Summation moment at any point equals 0. But before doing this, I would like to remind you for something very important. Sometimes we are given uniform distributed load. This uniform distributed load will be given with a value, W. In this case, the value of W equals 500 pounds per foot. And the total length of this uniform distributed load, capital L. In this case, the total length of the distributed load is 12 feet. What we are going to do with this distributed load, I will convert it to equivalent. Where? At the midpoint or the mid distance. This one will be L divided 2. This one will be L divided 2. How much will be the value of the distributed load W multiplied by the total length of the distributed load capital L? That makes sense? So in this case, I will convert this distributed load to equivalent, located here at the mid distance, 6 feet and 6 feet. How much? It will be 500, the value of the distributed load, times the total length, which is 12. So it will be 6,000 pounds. Now I am ready to apply my equilibrium equations. Summation f of x equals 0. I have positive XA. Nothing else. Nothing else in x direction. So your XA will be 0. This is the first reaction for XA, 0. Summation f of y equals 0. I have positive YA. I have positive YB. I have negative 6,000 equals 0. We cannot do any more for this equation because we have 2 unknowns. Summation moment. I do recommend to take moment at A, the point with the highest number of reactions. I will assume my clockwise rotation will be my positive. So, XA time distance, YA time distance. 6,000 time distance. And YB time distance. And the 900 does not need distance. And the 900 does not need distance equals 0. Keep in your mind, we have this 900 as a moment, does not need distance. And this 900 as a moment does not need distance. Don't forget any to be included in this equation. I am sitting at A, so the distance between XA and A, 0. YA and A, 0. 6,000 and A, 6 feet. YB and A, 12 feet. I don't care about the sign of this term or this term. Based on my assumption, clockwise rotation is your positive, so 6,000 times 6 will be positive clockwise. YB going up, so it will rotate counterclockwise, it will be negative. This given 900 is positive clockwise. This given 900 is counterclockwise, it will be negative. The only unknown in this equation is YB, so the reaction YB will be 3,000 pounds. So this reaction equals 3,000 pounds. If you put here YB 3,000, I can find out the value of YA, it will be 3,000 pounds. So this reaction equals 3,000 pounds. This is the first step, how to figure out the reactions. Second step. At your point, which is point C, I will do cut. I will cut the beam to 2 parts at point C. That I'm looking to figure out the internal forces. This cut will divide your beam to 2 parts. Part on the right hand side, this one, or part on the left hand side, this part. Which part I'm gonna use, it's up to you. I can use the right part or the left part. For me, I'm gonna use the right part. So this is step number 2. After you did section, I have the right hand side part. Here is your cut. Here is point C. Does that make sense? We have at this location point B with a reaction 3,000 pounds. This is point B. And this is reaction YB. And we are given here 900 pound-foot. And this distance equal 6 feet. And this distance equal 3 feet. What else? What else do you have on the right-hand part? I think we have this part of the distributed load with a value 500 pound per foot. This is everything right now on the right hand part. At your cut, I will put here axial force, capital N, parallel to the beam. I will put here capital V, perpendicular to the beam. I will put here capital M to create a moment on the beam at point C at your cut. Once you set up the part I'm gonna use, once you set up the internal forces at your cut, then I can apply the internal forces one more time. Summation F of X equals 0, summation F of Y equals 0, summation moment at any point equals 0. That makes sense? But before doing so, we have a new part of the distributed load with a value 500 and a total length 6. That means I need to convert it to equivalent, new equivalent. 500 times 6 equal 3,000 pounds. And this distance will be 3 feet, and this distance will be 3 feet. That makes sense? Then go ahead and start to apply your equilibrium equation. Summation f of x, we have only negative n equals 0. So your value of n will be 0. Summation f of y, we have positive v, we have negative 3,000, we have positive 3,000. This one and this one equals 0. So your v will be 0. That's fine, no problem. Summation moment, I do recommend to take moment at the point of cut, C. Then I will assume my clockwise rotation is my positive. So, capital N time distance, capital V time distance. Your capital moment does not need distance because it's a moment. 3,000, the equivalent of the distributed load time distance. YB, which is 3,000 time distance. And then 900 does not need distance because it's a moment, equals 0. I have to list everything. What is the distance between capital N and the point C? We don't have distance. Capital V and the C, we don't have distance. Capital M does not need distance. What is the distance between the 3,000 at this point and the C? It's 3 feet. What is the distance between the 3,000 at point B and the point C? 6 feet. And the 900 does not need distance. This term will be 0. This term will be 0. This moment, based on your assumption, will be positive. The first 3,000 times 3 will rotate clockwise, positive. The 3,000 times 6 will be negative. The given 900 is positive, clockwise. The only unknown in this equation is your capital M. Your moment will be 8,100 pound-foot. Let me check it with calculator. Yes, 8,100. So by the end of this problem, I can say at this point C, inside this beam, we have 3 internal forces. Axial force equals 0, shear force equals 0, your bending moment equal 8,100 pound-foot. That makes sense? Let me do another example. This example. We are given a beam and we are looking to figure out the internal forces, axial force, capital N, shear force, capital V, bending moment, capital M, at a specific point C inside this beam. First step, I have to start with reactions. That means I have to set up my reactions. A is a hinge, so I have 2 reactions. XA, YA. B is a roller, so I have only 1 reaction, YB. Then I am ready to apply the 3 equilibrium equations for reaction. Summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. Before doing this, I have also uniform distributed load with 9 value, 9 kilonewton per meter, and the total length equals 3 meters. So I will convert it to equivalent, where mid distance from this side and the mid distance from the other side. How much? 9 times 3 equal 27 kilonewton. Then I'm ready. I am ready. Summation f of x equals 0. I have only positive XA, nothing else, equals 0. So this reaction will be 0. Summation f of y equals 0. I have positive YA, I have positive YB, I have negative 12, I have negative 27 equal 0. So YA plus YB will equal 39. Summation moment at any point, I do recommend to take moment at the point A with the highest number of reactions. I'm gonna assume my clockwise rotation is my positive. So XA time distance, YA time distance, 12 time distance, 27 time distance, YB time distance equals 0. What is the distance between XA and A? 0. YA and A? 0. 12 at this point and A? 1.5 meter. 27 at this point and A? It's 4.5 meter. YB at B and A? It will be 6 meter. This term will be cancelled. This term will be cancelled. 12 times 1.5 will rotate clockwise, will be positive. 27 will be clockwise, will be positive. YB rotating up, it will be counterclockwise, negative. The only unknown in this equation is YB. I can figure out the value of YB. It will be 12 times 1.5 plus 27 times 4.5 divided by 6. I got 23.25 pound. If you go back here and put YB 23.25, I can find out the reaction YA. It will be 15.75. So this reaction equal 15.75. This reaction equal 23.25. This is the first step, reactions. Let's start with the second step. Second step, I will do cut. Second step, I will do cut in this beam at point C. This cut will divide your beam to 2 parts. One of these parts is the part on your right. So I'm gonna use the right part. Or I can use the left part, but I do prefer to use the smallest part. So this is the second step after you did your section. I have the right part. I did cut here at point C. This point is point B. At B, I have vertical reaction YB equal 23.25. That makes sense? On this part, this is little part, I have part of the distributed load, 9 kilonewton per meter. Keep in your mind that this part with a distance or a length equal 1.5 meter. Nothing else. Nothing else on the right-hand side part. But at your cut, I need to put the 3 internal forces. Capital N, parallel to the beam. Capital V, perpendicular to the beam. And the capital moment to make moment. We are ready to apply the 3 Coulomb equations one more time, but only for this part. Summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. Before doing this, remember, we have a little part of the distributed load, so I have to convert it to equivalent. How much? 9 times 1.5 meter will be 13.5 kilonewton. The position of this equivalent will be half distance from this side and half distance from the other side. Half distance of 1.5 will be 0.75 meter, 0.75 meter. Then we are ready. Summation f of x equals 0. We have only negative capital N equals 0. So capital N will be 0. Summation f of y equals 0. We have positive V. we have negative 13.5, we have positive 23.25 equals 0. So your capital V will be negative, how much? (9.75 kilonewton). Summation moment. I do recommend to take moment at C, the point of cut. And I will assume my clockwise rotation is my positive. So, capital N multiplied by distance. Capital V multiplied by distance. Capital M does not need distance because it's a moment. 13.5 time distance. Your reaction YB 23.25 time distance equals 0. What is the distance between capital N and your point C? 0. Capital V and point C? 0. Capital M does not need distance. What is the distance between 13.5 at this location and the point C? It's 0.75. The distance between YB at point B and C, it's 1.5. I don't care about this term. I don't care about this term. Based on my assumption, this M is clockwise, which is positive. 13.5 will rotate clockwise, positive. Your reaction will rotate counterclockwise, will be negative. The only unknown in this equation is your capital M. Your value of M will be positive 24.75. Positive means your direction is correct. Negative means the shear should be down. So by the end, I can say the axial force at this point C in this beam equals 0. The shear force is 9.75 going down, and the bending moment 24.75 rotating clockwise like you did. Does that make sense? We have another example. This one. We are given a beam. This beam is supported by hinge at A. And we have a cable connected to a hook at B. If you would like to start to solve this beam, I will remove the cable. If you would like to remove the cable, then I will put here a reaction on this cable, R. This reaction R is supported by this hook to support your beam. And we are given this force 20 kilonewton. At point B, at point A, it's a hinge. So we will have two reactions, YA and XA. That makes sense? That makes sense? So the new idea in this problem, if you have a cable, then I need to remove this cable and put only one reaction in the same direction of the cable. Then I'm ready to apply your equilibrium equation, summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. In x, we have negative xa, we have positive r equals 0. In y, we have negative 20, we have positive ya equals 0. So ya will be 20. Summation moment, I'm gonna take moment at A. I'm gonna assume my counterclockwise is my positive direction. So taking a moment at A, xa times z time distance, ya time distance, 20 time distance, and your r time distance equals 0. Keep in your mind, we are sitting at A. So the distance between XA and A, 0. YA and A, 0. Between 20 and A, the whole distance is 2.25 meter. And the distance between the position of R and A, this distance will be vertical distance because your force is horizontal. I think this distance will be 0.6. It's not 0.5, 0.5 to this center only, but I have to add the radius. So the total distance will be 0.6 because I have 0.1 radius. So 0.6. This term is 0. This term is 0. 20 time distance will rotate counterclockwise will be positive. R time 0.6 will rotate clockwise will be negative. The only unknown in this equation is your R. Your R will be 75 kilonewton. If you go back here and put R 75, your XA will be 75. So this reaction is 75. This R equals 75. This YA equal 20. This is the first step, reactions. The second step, I will do cut. We are given point C here. So I will do cut at point C. This point C, or this cut, or this section divided your beam to two parts, one on the right-hand side or one on the left-hand side. I'm gonna use the right-hand side. So after you did your section, I have this right-hand side part. Here is your cut at point C. Here is your point A, I think. We have at A two reactions, 20 YA and reaction XA equals 75. This distance equal 0.75 meter. Nothing else. Nothing else. After you did cut, I decided to use this part. I have only two reactions, nothing else. Then go ahead and put your internal forces, capital N, capital V, and the capital moment. Then apply summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. You can get your reactions. Does that make sense? So summation f of x equals 0, your capital N will be negative 75. Summation f of y equals 0, your capital V will be negative 20. Summation moment at your cut C, assume this direction clockwise is your positive. Your capital M will be 15. These are the three internal forces at point C. This one kilonewton, this one kilonewton, this one kilonewton meter. Positive means you assume there's a correct direction. Negative means you assume there's a wrong direction. That makes sense? We have a new idea in this problem, which is very important. Let's see. We are looking for the same also. We are looking for the internal forces, axial force, capital N, shear force, capital V, bending moment, capital M, at point D. We can figure out the internal forces in this problem without reaction, but we need to calculate reactions to cover this new idea. We are given A is a hinge. That's fine. We have two reactions. And we are given a new member here called the CB. This member is called two-force member. This member is special. This member has two ends, C and B. C is a pin, B is another pin connected to the beam. If you would like to start to figure out the reactions for this kind of problems, I will remove the member CB. I'm gonna remove member CB, which is 2-force member. Forget it. And then I will put a reaction at B on the same direction of this member. That makes sense? So this 2-force member will provide, this member will provide a reaction, one reaction to the beam in the same direction of the member. Since this member is inclined like this, your reaction will be inclined like this. This angle theta will be the same like this angle theta. Does that make sense? This is a special case, special member called 2-force member. If you have this case, I'm gonna remove it, delete it, forget it, and put one reaction in the same direction of this member. Besides, at A, it's a hinge. So I will have YA and XA. It's a hinge, regular hinge. Besides, we are given this concentrated force 800 Newton and this force 600 Newton. And also we are given a moment here 900 Newton meter. Does that make sense? Go ahead and apply summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. We are ready to figure out the reactions. But keep in your mind, I cannot start right now until you break this reaction to two components. The horizontal one will be r cosine, the vertical one will be r sine. And also keep in your mind that this angle theta will be inside this right angle triangle. This horizontal distance is 2. This vertical distance is 1.5. So the hypotenuse, I think, will be 2.5. Let me check. 4 plus, yes, 2.5. So I can say sine theta will be 1.5 divided by 2.5. Cosine theta will be 2 divided by 2.5. That makes sense? Just to give you a hint. If you apply summation f of x equals 0, I have negative xa, I have positive r cosine theta, nothing else. Yes, I do have cosine theta equal 2 divided by 2.5, but I'm still having two unknowns, xa and r. I don't know any of them. So leave it. Summation f of y equals 0. We have in y positive ya. We have positive negative 600. We have positive r sine theta. We have negative 800 equals 0. Yes, I do have the value of sine theta equal 1.5 divided by 2.5. However, ya and R still unknowns. I cannot do anything more. Leave it. Summation moment at any point equals 0. I do recommend to take moment at A, which is the point with the highest number of reactions. I'm gonna assume my clockwise rotation is my positive. Then I need to multiply XA time distance, YA time distance, 600 time distance, R cosine theta time distance, R sine theta time distance, 800 time distance, and 900 does not need distance, equal 0. Be careful. Be careful. And pay attention for this. 900, this one is a moment. Does not need distance. So don't think about any distance for this moment. Let's say we are sitting at A. So the distance between XA and A, 0. YA and A, 0. 600 and A, I think between 600 and A, this distance equal 1 meter. R cosine theta here and A, 0. R sine theta and A, it will be 2 meter. Hey, wait. R cosine theta at point B. R sine theta also at point B. So why one of them has a distance 0 and one of them has a distance 2? First of all, the distance between B and A, yes, it's 2 meters. But keep in your mind, R cosine theta is a horizontal component. If your force is horizontal, your distance must be vertical. Do you have a vertical distance between B and A? No, your distance will be 0. R sine theta is a vertical component. That means your distance will be horizontal. Do you have a horizontal distance between the two locations? Yes, 2 meters. 800 Newton at the end, and the point A, the distance will be 4 meters. And the 900 does not need distance. It's a moment. I don't care about this term. This term, 600 times 1 will be clockwise positive. I don't care about this term. This component time 2 will be negative counterclockwise. This one will be positive clockwise. This one is positive clockwise. The only unknown in this equation is your reaction R. So what will be the reaction R? So I have 600 times 1 plus 800 times 4 plus 900 divided by 2 times sine theta is 1.5 divided by 2.5. Wow, I got very huge number. 3,916.67. Let me check this value one more time. So I have 600 times 1 plus 800 times 4 plus 900, yeah, divided by 2 divided by sine, this angle is 1.5 divided by 2.5. Yes, my number is correct. Once you get the value R, I can go back here and put R with this value, 3,916.67. I can find out the reaction YA. The reaction YA will be 950. So this reaction is 950. I can go back here and put R with this value, 3,916.67. I can find out the value of X8 will be positive. It will be 3,133.3. So I found the two reactions at A. I found the force in the inclined member, which is called two force member. Now, I need to figure out the internal forces, axial force, shear force, and the bending moment at point D. The next step, I will do cut. Then I will decide to use the right part, this part. Because we have another option to use the left part. The left part is more complicated. We have many things, and both of them will give you the same answer. So we need to select one of them. So if you decided to use the right part will be like this. So step number 2, your section. I have this little part. Here is your section. This point is called D. At this position, I have 800 as a force. I am given a moment as 900. What else? Nothing else. The length of this part is 1 meter. Should be given. We are ready. I have axial force, capital N. I have shear force, capital V. I have bending moment, capital M. One more time, go ahead and apply your Coulomb equation. Summation f of x equals 0. Summation f of y equals 0. Summation moment at any point equals 0. You can find out your internal force. I think capital N will be 0. I think positive V minus 800 will be 0. So your V will be 800. If you take moment at D, if you assume clockwise rotation is your positive, so capital N time distance, capital V time distance, your capital M does not need distance, and we have 800 time distance, and we have 900 does not need distance, equals 0. 800 will be multiplied by 1, V and N will be multiplied by 0, based on your assumption. This term will be 0, your capital M will be positive, your force 800 will be positive, your moment 900 will be positive. The only unknown is your moment will be negative. It will be 1700 Newton meter. So this is your axial force, this is your shear force, this is your bending moment. So the new point in this problem for your reactions, we have one hinge at A, and we are given a two force member, CB. This two force member is a special member. You can remove it and put one reaction R in the same direction of this member. The same direction exactly. And this is the reason why this angle is the same like this angle for the member. Then I can start and apply my Coulomb equation, summation f of x, summation f of y, and summation moment. So you can find out your reactions. I believe I covered this kind of problem in the reaction module. Do you remember? Anybody remember what is the meaning of this member? Two force member. What do you mean? I mean, I can delete this member and draw this beam like this. At point B, we have one reaction, or this reaction in the same direction of this member. At point A, we have hinge, so we have two reactions, XA and YA. And we have uniform distributed load. 5 kilonewton per meter. This angle is 45 degrees. This one will be 45 degrees. So we have two components here, the horizontal one and the vertical one. R sine, R cosine. Anybody remember how can I convert this distributed load to equivalent one? It will be here. How much? How much? 5 times 6, 30 kilonewton. Go ahead and figure out the reactions. Summation f of x equals 0. So xa plus r cosine 45 equals 0. Summation f of y equals 0. So ya plus r sine 45 minus 30 equals 0. Take moment at A equals 0. Assume this direction is positive. So we have r sine 45 times 3 minus 30 times 3. So I assume this one and this one will be cancelled. The only unknown in this equation is R. So R value will be 42.42. So R equal 42.42. So the vertical component will be 30 and the horizontal component will be 30. So this reaction will be 0 and this reaction will be negative 30. XA will be negative 30. Negative means in the opposite direction. YA will be 0. So guys, the final conclusion for this beam, something looks like this. Here is the final conclusion. Here is point B. Here is point A. We have horizontal reaction like this, 30. Like this, yeah. You assumed it like this and your answer is negative. So the correct direction must be like this. This reaction is 0. We have here R. This R give you vertical reaction 30 and the horizontal reaction 30. And we have uniform distributed load. 5 kilonewton per meter. I'm gonna forget this R because you already have vertical and horizontal one. This is the first step, reactions. I didn't read the problem. Okay, go back and read the problem. We are looking for axial force N, shear force V, bending moment M at point C. Here is point C. We have here a point called C. What should I do the next step? Make a cut at C. Make a cut. We have two options. The right part with all of this stuff, or the left part with very little stuff? What do you think? This distance is 1.5. I will decide to take the left part. I did cut here. What do you have? I have vertical reaction 0. I have horizontal reaction 30. I have a little bit of the uniform distributed load. And this distance is 1.5. At the cut, we have normal, we have shear, and we have moment. Don't forget, we have a little here of uniform load. We have 5 times 1.5. How much? 7.5, yeah. Go ahead and apply summation f of x equals 0. NC will be 30. Summation f of y equals 0. VC will be negative 7.5. Summation moment at point C, and I will assume this direction is positive, MC will be negative 5.625.